Hey, so today I'll be talking about my big project in quarter two.
This project aims to see and understand about the relationship between pressure and volume through Boyle's law theory. By that, the result of this project will then explain how the relationship happens between pressure and volume and why did it happen and what is actually the Boyle's law. Throughout the experiment, question and practices and also experiment will be done based on the relationship between pressure and volume to show examples and prove the Boyle's law theory. So, as a background information, during around mid of the year 1600, Robert Boyle studied the relationship between pressure and volume at a constant temperature, and he found out that at a constant temperature, the pressure and volume for gas is almost constant. So he came up with a theory that at a specific temperature and having a specific amount of gas, the pressure and volume will be constant. This is shown through a formula P times V equal to N times R times T. This formula stated that pressure and volumes are constant at a constant temperature, and pressure and volume are inversely proportional. So at the beginning of this project, I have started with researching for information about Boyle's law, and as soon as I get the information as much as I want, I start with one practice and then another experiment. So the practice was the graph. So first I got a set of data which showed the pressure and volume table. And so I took that and put it in GeoGebra and graph it out and see the connection between pressure and volume. The result came out that volume and pressure are inversely proportional. So as volume increases, pressure decreases, and as pressure decreases, volume increases. And it also showed that at a specific point or specific time, there will be a specific volume and specific pressure. We can use the graph to also predict what will be our pressure and volume at this time, at what time we want, from the graph we have come up with. It is a power function graph. Why is it a power function graph? Because when we're graphing it out, I've tried using all the possible graphs. And the power function graph is the one graph that the line actually goes through every single point on the graph. And it actually shows that pressure and volume are inversely proportional. So it's a very useful graph. We can use it in our real life. So the next one is the experiment, which I use the sign ring for it. So during the experiment, I have done it two ways. The first way is closing the tip of the sign ring and try to push the plunker of the sign ring in and see what happens. And the other one is opening the tip of the sign ring and try pushing and pulling out the plugger of the sign ring, and the results were amazed. In the case of when a plugger is pushed in while the tip is closed, there is a limited amount of space inside the sign ring. So as we push in the plugger, it limited the amount of space, which is the volume we have. Then as the smaller we got, the more pressure we have, because the gas, the air inside, they collide more to each other, causing more pressure. And when we pull it out, as soon as we pull it out, the volume increased because the space increased, and then the pressure got lower because the gas are not colliding as much anymore. In the case of when the tip of a sign ring is open, then there won't be any change in pressure and volume. It's because when there's no limited amount of volume, then the pressure doesn't change. So the results came out that no matter how much I try to pull or push the plugger, then at the 10th time, there's no different from the first time I've done it. So pressure and volume doesn't change. This experiment shows that pressure and volume are inversely related, and pressure depends on volume. If the volume increases, then pressure decreases. And if volume decreases, pressure will increases. Now, as a conclusion, this project has been done to prove the Boyle's law statement and answering how pressure and volume are inversely proportional. So during the process of this experiment, information has been gathered to prove the Boyle's law statement. And according to the Boyle's law statement, P times V equal to N times R times T. And it shows that pressure and volume are inversely proportional. Then why is it so? It is because as volume decreases, the space became smaller, and then That causes the gas or the molecules to collide more, causing collision between the molecules and causing higher pressure. Then, what will happen when volume is increasing? Of course, pressure will decrease because the collision between molecules got smaller. There are more space between molecules, and so there is lesser pressure than before.
So, throughout this quarter 2, we have done many standards such as the following. Now, let's talk about each standard one by one. So, the first standard is FIF7C. The standard is graph polynomial functions, identifying zero when suitable factorization are available, and showing end behavior.
Then, why are we learning about this standard? We're learning about this standard because it's important for us. We can use it in our real life. So, we have to know this in order for us to be successful in our business. Then, how can we use it in our real life? An example to this is an example about finding a population in a certain time. For example, you have collected a set of data which show the population of Thailand people throughout the year 2000 to 2015. Then, you can use polynomial graph to graph it out. Then, you can use it to predict the population in the future. For example, you can use it to predict the population in the year 2017 or 2020, and you can know the future. So, if we want to use it in our business, we can use it to predict the future income or the future popularity your business will be. Who will know? So, this will be very useful for us, and we can actually predict our future.
The next standard is FIF7B. It is graph square root, cube root, and piecewise defined functions. Includes steps functions and absolute value functions. An example to this standard is when we're playing pool.
If we're playing pool and we have a ball at a certain point and we want to hit a ball, another ball which will go in the hole and make us a point, we can come up with an equation and graph it out and see whether if we hit this point, will it hit the ball and go into the hole. So, how can we use it in our real life? We can use it in our real life to predict our income for our business. We can use it to look whether at this point, will our business be successful? Will we be able to be successful at this specific point? And will we reach that specific point? So, it's very useful for us, and it will be very useful for our future.
So let's go to the next standard. It is FIF6. So the standard is calculate and interpret the average rate of change of a function, present symbolically or as a table, over a specific interval. Estimate the rate of change from a graph.
So in this standard, it can help us to calculate the rate of change. So an example to this is, if we have a data of a price and cost, and we want to calculate the rate of change as it goes down the table, we can use this standard to help us out. We can use the formula delta y over delta x, and it will give us the answer, which is the rate of change. And so, how can we use this in our real life? So, we can use this standard to predict the rate of change in our business. For example, we want to know the income from last year to this year, the rate of change from 2 years ago, 3 years ago, to 10 years ago if we have the data. We can use it to see whether the rate of change got better, whether we got more income, or whether we got lesser income looking through the rate of change.
So the next standard is FIF5. The standard says that relate the domain of a function to its graph and where applicable to the quantitative relationship it describes.
So, for example, if a function h of n gives the number of person to hour it takes to assemble n engines in a factory, then the positive integer would be an appropriate domain for this function. This standard will help us to know what will be an appropriate domain for the function. Appropriate range for the function will it be positive, negative, or will it be from 0 to 1 or 0 to 20. We also should know what the y-intercept and x-intercepts mean and the slope. So, how can we use it in our real life? So, we can use this in our business again. We can use this to see the number of the best choice for our business. For example, finding the best choice for the cost or the amount of product for the number of customers. We can see the range from a specific number to another specific number, seeing that as our best choice and choosing that for our best profit for our business. So, this is very helpful, and we can really use it to gain a lot of money for our business.
So, now it's FIF4. The standard states that for a function that models a relationship between two quantities, interpret key features for graphs and tables in terms of quantities, and sketch graphs showing key features given a verbal description of the relationship. Key features include intercepts, intervals where the function is increasing, decreasing, positive, or negative, relative maximums and minimums, symmetries and behavior, and periodicity.
An example question for this standard is, the cost for selling IT products for an IT shop can be modeled in a linear function with a slope 50 and start volume 4,500 baht. What is the y-intercept in this model, and what does it mean? So this standard will teach us how to graph a function and teach us what is the y-intercept and the x-intercept mean. The question in this standard also asks us what is the x-intercept for this function and graph it out. So as we graph it out, we can learn to understand more about the x and y-intercepts and learn how to sketch graphs.
So, how can we actually use this in our real life? We can use this in our real life to be able to predict the best income for our business again. So, we can use the graph to see whether the income will be good or not. And we can see the x and y-intercepts and say that this will be bad because the x-intercept is too low, the y-intercept is too high, or the y-intercept is not good enough. So, we can also see the maximum and minimum of a vertex in a parabola and saying that, will that be good for our business? Will the income be as high as the maximum? Will we get that? Will we reach the point where we want? And will our income profit us? So it's very useful and we should know this in order for us to be successful and to be able to see the income for our business.
So, last but not least, the last standard is SSE2. The standard says that use the structure of an equation to identify ways to rewrite it.
So example to this standard is all the groupings, the quadratic equation, the quadratic expressions, and finding the GCF. We can use all of this in our real life too. So how can we use this in our real life? We can use this in SAT testing and entrance exam. So all of this is very useful for us because in order for us to get in a university, we have to know this, and it's very helpful for us.
So that's all the standard in quarter 2, and as you can see in my progress, I get pretty good scores, but some may not be so good, so I still have to fix some of them. But I'm quite proud of myself, and I want to thank you to Mr. Freddy who teaches this standard, and it was really helpful. So I hope you enjoyed this video, and thank you for watching. Bye!